Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. Let's now factor this binomial here. And according to our guide, we should start with the common monomial factoring before everything else. Because if we are going to start with the next processes as to identifying whether it's difference of two squares, difference of two cubes, factorable polynomials, etc., perfect square trinomial, it will actually complicate things if we cannot look for a common monomial factor. Of course, if you could just jump into conclusion like the first term is a perfect, has a numerical coefficient that is a perfect square, that's 16, and the second term's numerical coefficient is also a perfect square, 100. And since it's both terms are separated by subtraction, and you might decide, oh, this is difference of two squares. Well, probably we could get to that later, but when you look at our literal coefficients rather, or the variables, noticeably, the exponents are odd numbers. The exponent of the first variable of x is 5, and the second is 3. In short, even if the literal numerical coefficients rather 16 and 100 are perfect square, the literal coefficients x, specifically x to the power 5 and x cubed, are not perfect squares. In short, that is we cannot use difference of two squares here yet. I mentioned yet because, as mentioned in our guideline or our guide earlier, let's start with the common monomial factor. So let's factor it here. Okay. Now, the common monomial factor talks about the common or the greatest common factor that we could take from both numerical and literal coefficients. Let's look at our numerical coefficient. You have 16. And we have here 100. What do you think is the greatest common factor? The greatest common factor for both of them is 4. So we take out 4. Okay? So that's the first step. Okay? Once we take out 4, we know what will happen to the respective numerical coefficients. But let's do it after we take out our literal coefficients here. When we take out literal coefficients of the same variable, you have x to the power 5 and x cubed, you always use that same variable and the lower or the smaller exponent 3. Because this is good for x to the power 5, this is x cubed times x squared. So you can move that out. Because if you're going to remove x only, you're not yet done. If you're going to remove x squared only, you're not yet done. If you're going to remove x to the power 5, that's not possible for our second term. So this is our greatest common factor. Then we have here the binomial. The binomial is the result after removing this greatest common factor to both terms. So let's divide this one. 16 divided by 4, I still have here 4. And x to the power 5 will become x squared. You can always check this one using distributive property. 4 times 4, 16. X cubed times x squared, x to the power 5. We meet the first term. And of course, the second term will start with subtraction because it's subtraction here. To be divided, 100 to be divided by 4, you'll get 25. As for our literal coefficients, since we take out x cubed, we don't have a variable remaining here, so it stays as it is. This is the process after taking out our greatest common factor. But we are not done yet. because if we're going to look closely at our term here, our binomial here, this meets the criteria of a difference of two squares. Difference, 25 is a perfect square, check. 4 is a perfect square, and x squared is a perfect square. So we can now factor this out. The next factor, of course, you're not to remove this monomial because it stays as it is. And then you will have here the factor for your difference of two squares. The factor for difference of two squares are two binomials separated with a term separated by opposite signs. You could use plus here and minus in the second, no, regardless, since they are binomial and they are to be multiplied and multiplication is commutative, they're just the same. Since we are sure that this binomial is a difference of two squares, we're going to do it like this. Take the square root of the first term. Square root of 4 is 2. Square root of x squared is x. You copy the same term here. Then, square root of 25 is 5. You copy it the same here. So this is now the more complete factors for this given binomial. We did not start with difference of two squares because the little coefficients do not meet that standard. We took the greatest common factor for both terms, and then after here, this can still be factored further using difference of two squares. Hence, we have this. All of these three factors should be placed in the final answer, not just these two, because these three will come up with this here. So this is now the result for this given binomial. The next factor we're looking for is for our next subscriber. Subscribe now!